Hello and welcome to the OWASP DevSlop Show, a DevSecOps jungle gym of disasters. I'm here, Amy, with my co-host Nikki, and we're going to talk to Anais Urlichs today about containers and how to tame them with Kubernetes. And of course, we wouldn't be a proper OWASP show without a side of cloud native security. So
Yeah. Well, all right. Anais is a site reliability engineer at Civo, a cloud computing company based on Kubernetes. When she's not advocating DevOps best practices, she runs her own YouTube channel centered around cloud native technologies. Before transitioning to that cloud native ecosystem, Anais helped blockchain projects scale and find adoption. As a recent winner of the CNCF Top Ambassador of the Year award, her passion lies in making tools and platforms more accessible to developers and community members. Welcome to the DevSlop Show, Anais.
Hello, so great
hey,
to be here.
Great
Thank you
to
so
have
much
you.
for the lovely introduction. That's amazing. So we're going to talk about containers, how to manage containers with Kubernetes. It's going to be an introduction to both, and then I will provide an overview of the different security vulnerabilities or best practices that you should be aware of when getting started with Kubernetes and containers. And then I will also give a little demo of some of the tools that I really enjoy using in the cloud native ecosystem. And hopefully we have lots of time for your questions. And I get to talk a bit about of the books at the end about different questions that you might have. So yeah, let's dive right into the presentation now.
Yeah.
Oh, somebody just rang my doorbell, but let's go for it. That person can wait. That person can come back. Okay, so containers in a nutshell. I'm German, so I love using and and so on. So pods, containers in a pod. I wanted to make this title a bit more fun, and really I thought about it at the beginning of let's make it introductory because cloud native security or security in general, I mean, it's a vast topic, right? There's so much we could be talking about. But I think since a lot of people are just getting started with Kubernetes and using Kubernetes to manage their containers, it's really important to also address like, okay, what should you think of at the beginning without becoming completely overwhelmed, because there are tons of resources and books and stuff that you can go ahead and start reading about cloud native security, but you'll feel easily overwhelmed. I guess that's what my experience is like. So I thought let's take a step back and talk about what you can do right at the beginning. I'm really active on Twitter, so you can find here in the corner my Twitter handle at Urlichs. So if you have any questions, if there are any slides that you find particularly interesting, just tweet at me at Urlichs on Twitter. That's for the introduction. Let's go to the next slide. So a little bit of the overview of what am I planning to talk about. I like to outline the goals that I have in mind with using different technologies. So we talk about the goals first, and then of using containers and Kubernetes, and then I'm going to dive into cloud native security and 5 things you can do right now, and then a demo, and I'm going to show you some interesting resources that I found really useful learning about cloud native security. That's kind of the overview. So what are our goals when we get started with these technologies, with any technology, right? We have to think about where do we want to get at? Why are we investing the time, the resources to use those technologies in the first place, right? And well, first of all, when we use Kubernetes or when we adopt new technologies, what I'm really about is getting excited of using those technologies, right? Like I want to enable myself doing something that I wouldn't be able to do without those technologies. So I really want to focus on like, how can we get excited about those technologies? So we want to keep learning about them and enjoy using them in the long term, and they don't just become another thing that we have to manage, right? However, we don't use also Kubernetes and other really like other technologies to its best capabilities, we might end up in a position where we have lots and lots of manual tasks, where we just add up new tools to our existing deployment setup, right? And then at the beginning, it's obviously quite exciting of like, let's implement those new tools. But then it can easily become this situation where we're just stuck with these tools that we now have to end up managing, right? Or maybe we dump it to somebody more junior in the team and be like, here, it's your responsibility now to manage those, right? If we're working within a team. But if we're working just by ourselves on our own, maybe side projects, right? We have limited time, we have limited resources. We just want to keep being excited about the tools that we're using for those projects without being this middleman who has to take over all the manual tasks. Because ultimately, as humans, we are most effective doing the interesting jobs, the jobs that get us excited and really focus into this flow feeling versus doing all those manual tasks that get us really bored and have us make mistakes, let's say. So we want to prevent the situation. That's ultimately it. And when you're thinking about having our development workflow, and whether that's our own workflow or within our team, where we develop new features, where we fix bugs, where we expand our application, and we test those new deployments that we want to have in place, we set up security configurations, networking, and ultimately we end up deploying that application. Throughout this entire life cycle, let's say, we want to be effective, right? We want to get our new features out as fast and as effective as possible without having to set up everything from scratch every time we do something, right? Without having to check everything that we already put in place earlier. However, if we are in a large team and this is not effectively managed, this entire life cycle with the different technologies and tools that we have in place, and we have maybe slow communication between team members or teams, it could happen that this entire workflow can become really frustrating, and it might even take days or weeks or even months. And then if we have our application as part of interconnected processes with very low visibility into what's actually going on within the application, every time that we deploy a new feature, it could happen that we have to reassess all of our other configuration that might not have anything to do with, for example, a button change or a color change on our application itself. So we want to prevent ultimately these downsides of having interconnected processes, complicated dependencies within our application, and ultimately low visibility into our deployments, because that will prevent us making fast decisions and using those new tools and platforms such as Kubernetes to its best. So here are goals where we want to get towards, and why I'm really excited about Kubernetes and Docker, because I really think they help us to move towards these goals. The first one is having high portability between our different tools and platforms, right? We want to make our platforms work for us, our tools work for us, and not being stuck with what we have in place. And along those lines, we want to create an environment where we can work in a really agile manner and get new features and new respond to customer requests and our own requests in our side projects as fast as possible. But that's ultimately only possible if we have high observability into our deployments and we know exactly what's going on throughout our entire deployment workflow, our entire application lifecycle. However, the problem is, again, here, that this kind of comes at a trade-off. We can have all those amazing features, all the high observability, everything in place, but that could come again on us high operational management of us being this middle person of having to do lots of manual tasks to make everything work together. And that's obviously suboptimal, especially if you don't actually need those tools and we just use them because they sound maybe fancy. And then we want to keep our security risks low if we adopt new technologies and new tools. Just taking a second, there was background noise. And then, so ultimately my assumption here is, or like why I like personally Docker or like containers and Kubernetes, because they help us reach those goals and help us work more effective if done right. But then how do you do it right? And that's kind of what we're talking about. How do you move into a direction where you can use Kubernetes effectively without and securely without increasing or adding additional vulnerabilities and this manual management, those manual tasks in between your deployments. So how do you get there? Before I'm moving on to containers, are there any questions or any comments right now? Just between those different sections.
Yeah, there is one question quickly around just high level. What are containers, right? For a very new person to this whole ecosystem.
Yes.
You know, and I guess to piggyback on that, you know, you described the workflow and the simplicity of a Kubernetes-based workflow, or the intended simplicity.
Yeah.
When you're coming from a world that isn't that, you know, how do you explain like what this simplicity is based on what maybe an organization's current context is, sort of that migration to simplicity?
Yes, I will get there with the next slides, with the next section. So those are great questions. I hopefully will answer. If I don't answer within the next 10 to 15 slides, then please
Okay.
do let me know. I will address it separately. But yeah, great question. So what are containers? First of all, here's kind of an overview. Most people will come from the virtual machine environment. And in my first internships, when I did deployments, that's where I got started with virtual machines. Now we're moving into the container-based environments. And basically, what you have to think about, the main difference is the host operating system. So containers use the host operating system that's on the machine. They don't have their own guest operating system that they basically deploy. Like they don't simulate being its own standing machine. Containers, what they do is they basically, imagine this, you have your application locally running on, or you can spin it up locally with all of its dependencies, and it's all within your code. It's all like basically contained within your code. But then when you run it, you might end up using the resources from your machine where you run those, where you run your application on. So what you do with containers, you basically specify the different steps. Like you specify basically in a file called the Docker file, what you want to have packed up in this container. So it's like a box where you basically say, okay, this has to go into the box, this has to go into the box, and this has to go into the box of all, like everything that's related to your application, and all the dependencies that you need to run your application. Now with containers, what you want to do is every container should have ideally one specific task, like one job that it's made to do, right? So for example, you will have a container for your front end. That's sole purpose is running the front end. And then you will have a container for your backend with all of the dependencies that are needed for your backend. And with that, you can basically plug and play this kind of environment where you have different containers that all have one specific job. Now, if you think about this, if you have even like a small application, you might end up with 3 or 5 containers even, right? Maybe one, depending on how much you want to separate the different processes and dependencies within those different containers. But ultimately, when you run a container, like once you have basically built this recipe of what has to go into container, you can then build the container and you can run this container. So you can basically say, okay, now you want to run it and you want to access the application that's running within. So
Hold on. Okay.
Yeah.
So I just want to say containers have saved my life before at work because, let's say I'm in a different operating system than the application that I'm trying to run, right?
Yeah.
And I want to test a couple of different versions of, say, like, I don't know, a particular dependency like Java. I can do that with ease. But some people, I don't know how clear it is, how advantageous it can be to do that in such a lightweight format. So maybe speak to like I guess like a moment where you had, I mean, you've had like countless, I guess, um, places in your career where basically like it's been awesome to have a container. Tell me a great story, like where it saved the day
Oh,
having a
wow.
container in Kubernetes.
That's an amazing question. So just speaking about containers, I got started in this cloud native ecosystem a year ago. About a year ago was the first time that I actually built and ran a container. And it was as part of this CI/CD pipeline platform that I was working on. And what you can do is basically anything that you can basically run anything that you pack into that container image, you can run. So you can use this container and basically put it into different environments. So you can run it within if you heard of GitHub Actions, so similar to GitHub Actions and other CI/CD pipelines where you want to have a stage where your container image is built, and you want to have one where it's tested, and you can basically have those independent processes packed up as its own container. And I think that's really fascinating that you can basically how portable it is, right? You have this one container and you can put it into different settings, different environments, and it's gonna run there and it's gonna do its specific job. And you can specify, okay, once the job is done, should the container keep running? Should it stop? Should it be done with what it was supposed to do, right? So it's highly portable. It's really lightweight, and you want to keep it really lightweight as possible. So you can basically, as you build containers, you can specify once your dependency, everything has been built, only really the necessary parts for your application should then be transported in the final container image. And that allows you to really reduce the dependencies that your container has internally, and ultimately making it more secure and more lightweight. And that's what you want to aim for, because ultimately, if you have less resources that you have to manage, that's you have to pay less also to run those resources, right? So it's just like this whole ripple effect of once you start using containers, it comes with a lot of these additional benefits of running them. And is that good?
No, yeah, that was perfect. I was going to say my favorite part is killing off those containers that are not going to give me what I need for my application.
Exactly.
So I got you completely. Yeah, thank you.
Exactly. So, and ultimately, going back to what's the difference between running containers and basically your deployments as part of containers versus not. Think about when you have like a large application with like all its different dependencies and everything it's supposed to do, right? It can become in a large monolithic application really difficult to manage everything independently, to make changes on separate aspects of the application, especially if you're working across teams on the same application, right? And some people have to manage or work on one part, others have to manage and work on another part. It can become really difficult to update that. And what you do basically when you move to a microservice architecture is you break up that application into its different sections of like what can run independently from each other. It doesn't mean that they don't access information from between each other, right? So for example, in this case, service one will still communicate. You can still make it communicate with the other services, right? It's just that you should be able to update service one just independently without affecting the others and without affecting your networking and without affecting your security configurations or anything around it, right? So you want to have those basically containers just running what it's supposed to do. And containers are not long-lived. They live and die quickly. That's basically how you should think about them. So anything that has to be stored, all the information that have to be managed, they should be stored independently and should also be managed separately from those containers. Containers are really just what processes are supposed to run, whether that's the front end or an API or whatever it's supposed to do, right? So those containers, it's just basically your access points to do something, your tools, right? So it doesn't matter which scissor you use, and for as long as you have a scissor and you can access what you actually want to cut. That's basically it. Think about it kind of that way. But the problem with this is, and this is where we can move kind of into the Kubernetes purpose and direction, is that a lot of applications, a lot of companies such as Amazon or Netflix or other companies, also smaller companies, not at the size, they have lots and lots of containers that they will have to manage, right? Like think about all those different teams and they all have multiple containers and they all have to manage them independently, but also have common dependencies. And that's where Kubernetes basically comes in. It helps us manage those containers, because containers, you can spin them up and destroy them independently. But ultimately, if you would do that manually or through pipelines, it would be, again, a really extensive and complicated task.
Man, we have a couple of questions in the chat. I want to slow it down because you have like fired it up. Okay. So, and it seems that one of them is actually pertinent to your experience as an SRE. Someone was wondering if you can talk about your experience with containers, but from a performance and scalability perspective. That's one.
That's a great question. I mean, the thing is, that's kind of also where we're going to move more into the Kubernetes environment, is that you can ultimately, when you deploy your application, you want to make sure that it's resilient to anything that's thrown at it, right? So with Kubernetes and containers, you can basically tell Kubernetes, hey, you want to have 5 replicas of your container, of your deployment. So it's going to spin up 5 times the same container on your workloads. And we're going to get to that in more detail in this presentation. But you can basically say, hey, I want to have, just in case a lot of people all of a sudden want to access my website, I want to scale up my application to have 5 replicas, so 5 copies of my front end, for example, are running so people can access it, right? And then the load is kind of distributed across those 5 replicas. And that's something that's becoming really easy with Kubernetes to do. So you can basically specify if it's should auto-scale up. If there's more traffic, it automatically scales up. Or you can specify what is the maximum, what is the minimum it should run, depending on traffic that your application receives. And that allows you to long-term manage your application, make it more resilient to external input and basically the varying loads that your application might receive. Does that make sense? Is that good? Oh, I lost focus here.
No, you're good. I think that was a perfect transition, right? Probably into the next section. There's
Yeah.
also another question about security, but we'll get there because we have another section dedicated to that. So,
Okay. Yeah, exactly. So if there's anything still unclear, then please drop another message and I will address that. I will aim to address it separately. And that's
uh,
kind of like, yeah.
well, actually, we did get some feedback from the audience. They were asking
Okay.
for like a real
Awesome.
life case, it seems like. So, rather than a
Okay.
theoretical explanation of Kubernetes and how it
Okay.
works through scalability and all that.
Okay. Real life example. It's really, I mean, that's what you would ultimately do with most applications that basically you would want to have them respond to the load that you provide. But then also some applications, they require, for example, when you run, and this is getting more into the Kubernetes part. So I think I should talk more about this once I'm showing the Kubernetes examples on the drawings, because
Yeah,
those
makes
drawings will
sense.
make it more easier to understand versus me kind of with hand gestures trying to explain it. So we will get to it. I know it sounds like a lot right now, but you have to remember from these slides right now, and I will try to slow down, um, is basically containers. You pick up your application into a container, right? And this is a single instance of the application that you can run. It's like an end-to-end process that can pull in external information if it needs to, but it shouldn't. It should basically run as its self-contained unit, let's say, of a workload, right? And you can take it and you can spin it up, you can destroy it, and you can give it to Kubernetes to do more advanced use cases, more advanced examples with it. And we will get to that in a second. So think about this, right? If Amazon and Netflix, if they run, or like other companies, if they run thousands and thousands of containers, you can't spin them up and destroy them separately. And that's where we need to have something like Kubernetes that comes in and helps us manage those containers. And that's what we will get to. So can I see the slides again? Awesome. So if you've used Kubernetes before, I would love to hear what your thoughts are, if you've used them in production or in your test environments, and what your experience has been with Kubernetes, because lots of people, when they first get started with Kubernetes, it's really complicated. It can become really complicated really quickly, and I will address that as well in the next slides. So I'm just curious of like, if there are people who have used Kubernetes before, what have your experience been, whether that has been on an example demo cluster or on a large scale, more production focus environment. So how do you get started with Kubernetes? Kubernetes can be like other technologies, just a term that you throw kind of at your workload. So for example, I'm telling you, it's really difficult to manage lots and lots of containers. So I'm throwing Kubernetes at it and be like, you can resolve it with Kubernetes. No, that's obviously not how it works, right? We need to have reasons of why do we actually want to use Kubernetes. No, I'm telling you, if you have more complex applications, you're managing your containers independently will not be enough. You will waste your time. You will have a pain doing that ultimately. So I'm not just telling you to throw Kubernetes at the problem. It's going to be resolved, because obviously if we just introduce a new tool, we're going to end up having maybe less of our existing problems from before, but we're going to introduce ourselves to new problems that we then have to learn about and manage and address as well independently. So I'm ultimately not trying to tell you of just throw Kubernetes at it. And also when I'm telling you, okay, Kubernetes is amazing, I also want to keep in mind that it might be in your use case, it might not be the right thing to do, right? So I'm trying to specifically like explain more also on the next slide in detail of like, when would you want to use Kubernetes? With Kubernetes, it can end up easily that you have to you end up over engineering your application of adding more and more tools. And with Kubernetes, you have to manage the configurations, which are basically in YAML manifest, which is like this markup language where you define your everything related to Kubernetes. And it can happen that you end up with lots and lots of YAML files that you will have to manage, and with additional applications that you have to manage within Kubernetes. So it can easily become this over-engineered application. So if your goal is to just run a static website with your container, or like just as that is, then Kubernetes might not be the right thing for you. So I'm not saying it's this universal solution. Then we also want to solve actual business problems or actual problems we have. So for example, let's say we don't actually know what's the latency of our application, right? We want to have additional monitoring in place. We want to have that automated and manage everything in our application and also the monitoring tools in a cohesive way of like everything kind of has the same deployment strategies and is managed in a similar way, then we can use Kubernetes, for example, to make that more aligned with each other. And ultimately, we want to prevent wasting money and time. If we end up spending days and days to configure our applications and the tools that we use to manage our application, then it might also not be the right thing if that doesn't pay off long term, right? And ultimately, we want to prevent building unreliable and insecure services. So if we throw new technologies at our application to manage our application, but we don't know how to use and manage those new tools and technologies, then it could happen that we actually make our application more unreliable and insecure to additional outside factors, let's say. So we want to prevent these things. Like that's something else which I'm going to add up now to our goals of what we want to keep in mind. We don't want to over-engineer our application or run into those issues just by throwing a new tool at our deployment strategy. So my goal is always to keep it as simple as possible and then expand into more complex situations before. So if using a container to manage your application is enough, then that's maybe where you stop, where you don't need necessarily Kubernetes. But with Kubernetes, and I will show you in a second, you will get a lot of additional benefits that you might want to have long-term in managing your application and your deployments. So here we get to the Kubernetes part in more detail of what actually is Kubernetes and what does it have to do with containers. So imagine each of those pods. I don't know if you can see my mouse. Let's imagine each of those pods is one instance of your container, like one running instance. This pod runs one instance of your container. This pod runs one instance of your container, and these pods as well, right? So basically, imagine within your Kubernetes cluster, it's combined of several nodes. So those nodes, they can run your workloads, as in like they can run your pods, which run your containers. So let's keep it simple and say basically these run your containers, right? So what you basically do, you don't interact with those nodes necessarily directly. You will tell the Kubernetes API, please spin up 4 containers of my application. Go ahead and do that, right? I want to have 4 of them because that will make it easier, like long-term, for people to access my application and will respond to the different loads that I have, the different traffic loads that I have coming to my application. So Kubernetes goes ahead and it's going to schedule your containers, your pods, onto those different nodes. And so basically, if one of those nodes goes down, let's say node 2 dies off, people can still access your application in node 1 and node 3 because those nodes will still be alive and running your containers basically in those pods. Now, the pods are the smallest unit within a Kubernetes cluster. It's like the smallest thing that runs a workload. It can run one container, it can run many containers a pod, depending on how you specify it. So what we want to do is we want to make our application really resilient, right? We want to have, if a pod dies, and pods like containers, they die really quickly, we want to spin up a new pod in its replacement. We want to make sure that there are other pods that run exactly the same workload, have the same information that people can access when they access your application as well. So that's basically some of the benefits of Kubernetes. Now, where it gets more complicated is when you want to really think about the resilience of your application in running distributed workloads, right? You can, large companies or many companies who really want to have a resilient application that doesn't have any as low downtime as possible, you would want to have different Kubernetes clusters across different regions. So maybe one is in London, one is in New York, one is in Abu Dhabi, somewhere else, right? Anywhere. So you want to have in different regions, you want to have those Kubernetes clusters, and they all run exactly the same workloads. So independent of who's accessing your application, they should be able to access the application, and ideally, they should be able to access the application as fast as possible. And that's possible. That's easier possible when you have the exact same processes running across different regions. So, for example, I'm based in London, so I would want to access the cluster or like the services that you have spin up in London because it's faster for me to access than waiting for the reply from New York or somewhere else, right? Just as another example. So it's basically you can reduce latency by using Kubernetes clusters across different regions. You can have multi-region environments, and ultimately also the resilience of your deployments. That's some of the benefits that you can get with Kubernetes or using Kubernetes effectively. Are there any questions at this stage? Because I feel like that's like a point where I should ask for questions.
Well,
Yeah.
we do have our poll that over half the audience has used Kubernetes before.
Awesome.
So just so you have that
Okay.
context,
Okay, cool.
that level
Okay,
sets.
that's great. Perfect.
Specific questions around Kubernetes. I think just a lot of chatter around opinions on Podman and things like that. I don't see any.
Okay.
Amy, am I?
Yeah.
No,
There's
yeah.
this.
I mean, there is the
Okay.
cloud, the security one, but sorry, the
Yep.
yeah, but yeah, that's
The
it.
what?
Later, sorry.
Yeah.
I fumbled over my words. We both get to fumble over our words at some point in the show.
The question that we're
Okay.
going to tee up on security that we're going to get to during the course of the episode.
Yeah. So we're gonna get there. I just wanted to like set the stage,
Nope,
basically.
I think we're good.
Okay,
Yeah,
awesome. Because
you are
obviously
really explaining it.
everybody has different skill levels and is at different points. I don't know why my camera is not focusing. Yeah, so it might be like somebody has used containers before. It might be somebody is using Kubernetes in production, right? So you will have different stages, I guess. So I want to make this accessible. So, but yeah. So why would you want to use? Why would you want to use?
Here's where I always think it's so funny when we talk about Kubernetes and simplifying things, and then a slide like this comes up. But that's just my own.
I can't help myself. It's
I know.
Yeah. So the thing is, when you get started with Kubernetes, you will come sooner or later across this landscape. Now, this is the landscape that is basically the magic map across the Kubernetes ecosystem. That's kind of how you can think about it. Now, you will get lost in this. It's like a dark forest, okay? You will get lost on this map.
Don't scare people. We're trying to get them to go into this realm.
No, here's the good news. The good news is that you don't have to use most of those tools. You will not use most of those tools. I probably used around maybe 10 to 20 of these tools that are listed here, okay? I didn't use more than that. And you will actively learn also only about like a few. It really depends on what you want to use for your Kubernetes deployments, right? So you can dive into more detail into specific tools if they fit your needs and your deployment strategy and so on, right? Otherwise, you will not use most of those tools. You will just not go there, right? The thing is here that these tools, many of them are managed by the CNCF. So all those big ones here, specifically like Argo, Flux, we have here Crossplane, we have Kubernetes itself. They are managed by the CNCF. So they are under their governance scheme, let's say, and fit specific requirements. Now, why would you want to know that in the first place? A lot of these tools are open source. And when you use open source tools and when you use them for your deployments, you want to make sure that there's a community backing those tools, especially since a lot of these tools are open source. It's sometimes, and that's some of my experience when I moved from developer advocacy into SRE, I realized deploying the stuff on production is definitely not the same as using the documentation of those tools just for your demos, because ultimately you will not have the same level of examples and you will get stuck. So having the community backing those tools is really important and really useful because they will help you make the deployments happen. So that's kind of why I want to highlight this, but also because some of those tools are really, really amazing. I'm going to show into more detail Argo and why I think Argo can really help you in your deployment strategy. Yeah, so these are basically some of the tools, and some of them are really fascinating of what it enables you to do with Kubernetes, using Kubernetes. And basically that also highlights why once you get started with Kubernetes, you don't have to use any of those tools. But in the long term, it will really help you scale and advance your application. That's kind of what I want to get to, of like, yes, Kubernetes is complicated, complex, but ultimately you can have all those different features if you want to.
Yeah, so I think that's a really good point. Like a beginner doesn't need to worry about this stuff, right? Like when you're just learning Kubernetes, you could totally just learn it as just regular Kubernetes. You don't need any additional kind of plugins or tools. But I think as you grow and the world is kind of adopting this like large scale distributed computing environment, these tools are aiming to solve specific problems that you'll experience as you kind of continue on your Kubernetes journey. So I think you said that, but I think it's a really important point because sometimes people see all of that and they're like, oh, this is so much to learn. I'll never get through this. And it's probably not that relevant at this stage if you're a beginner.
Exactly. So, I mean, I got started with only like 2 tools here. I got started with Helm here and Argo. And that was kind of the first tools that I used. And I didn't care about any of the other tools. So really just those two. And you can ignore the rest. So you have to really get good and ignore everything else, basically. Now, when you are working, for example, in site reliability engineering in the cloud native ecosystem, you will end up using a lot of these tools just for the monitoring of your application, because a lot of these tools help you to understand how does your application behave under different conditions, how does it respond to failure, what is the error rate, and things like that, which you like. Those tools really help you then implement them basically on your Kubernetes cluster and get further insights into your application. But when you get started, it's most likely not needed that you use these tools in the first place, like right from day one. It's probably just over engineering makes everything more complex. It's really important at the beginning that you just get started with it and then expand from there. So here's some of the tools that I use a lot, or like that I really enjoy. So here in the middle, we have Prometheus, and Prometheus is used in the cloud native, but also in the non-cloud native ecosystem to monitor your applications, basically the metrics coming from your applications. So I'm using that on a day-to-day basis really heavily. And then we have here Knative. Now, Knative is a tool also based on Kubernetes, and it helps you to run serverless workloads on Kubernetes. Now, one of the main criticisms for Kubernetes is that you have lots and lots of YAML files that you have to manage, and with more configuration, more YAML files, you can introduce obviously more errors into your deployments, right? Knative helps you, if you have especially static workloads, to deploy those with as minimum configuration as possible. So it's one of those tools that I heavily used in demos, because it's really amazing to see how you can have also serverless workloads on Kubernetes, and you don't actually have to deal with all the YAML files to make simple deployments happen. And then the third tool that I will also focus on is Argo. Specifically Argo CD, which is used for our deployment strategy in Kubernetes-based environment. Now, I'm going to move on to different deployment models, and then in a second, I'm going to take a quick break if there are any questions. But I also want to make sure we have enough time for demos. So with Argo, the amazing thing is that, and that's kind of what I want to show in the demo as well, is that with your Kubernetes cluster, like you will have lots of complex configurations within your Kubernetes cluster, and you don't want to give everybody, especially developers, access directly to your Kubernetes cluster, because especially if they're not heavy Kubernetes users. Like there are few people, there are not that many people who are really good with Kubernetes. Like there's a huge skill gap in the industry of actually running Kubernetes-based workloads. And the people that can do it. So ultimately, the day-to-day developer shouldn't have to care about Kubernetes in the first place. Like that's not what this is about. We want to run Kubernetes-based workloads for all the benefits it can give us, but ideally, the day-to-day developer just pushes changes to Git. Then we have a pipeline that basically creates our container. And then once the container is created and everything is changed within Git, we want to have the agent, like something living in our cluster that pulls in the changes from our Git repository into our cluster. And for example, if we have made any changes to service number 2, the agent will then monitor Git and see, oh, there have been changes made to service number 2. Let's pull those changes into the cluster. So in Git, we have basically our desired state of what we want to deploy within our cluster. And then within our Kubernetes cluster, we just have our services running and then an agent that basically makes those deployments happen, so the developer doesn't have to access the cluster directly. That's like one of those aspects that can enhance the security of our Kubernetes cluster, and that we don't have to give everybody access to it, because once we give more people access to our Kubernetes cluster, you will have to deal with more configuration to ensure that people can only do the minimum with those clusters. Then modify or delete resources that shouldn't be modified or deleted. So last part, cloud native security, before I dive into the demo. Are there any questions right now that I could address, or before diving into that part?
Nothing.
Okay. But we do have a giveaway that I know some of you have been waiting for in the chat. I already saw it. You need to drop hashtag DevSlapLive to participate. We are giving away a 1-year subscription of codecloud.com. So it's a DevOps course provider, and just start dropping in the chat.
Awesome.
And we're going to announce the winner at the end of the episode. towards the end of the episode.
So you have 20 minutes. Go.
Yeah.
Time's ticking. Awesome. So cloud-native security. Well, now that we know all about containers and all about Kubernetes and why we would want to use it and all the benefits it can bring, how do we get started without exposing our application to additional security risks that shouldn't be there, basically? Now, here's from Red Hat's State of Security Container Security Survey. Here's some of the things that people have been worried about in terms of container security and their container strategy. The first one is that most companies don't have or don't invest into a container security strategy or don't have it detailed and basically don't really have a strategy. And that's obviously a problem if you get started with those amazing tools and you don't actually have a strategy of how do you use those tools securely, how do you make sure that there are no unnecessary vulnerabilities introduced into those workloads. Because ultimately a container doesn't mean that it's this walled garden where everything just inside stays inside and everything outside just stays outside, because as soon as people can access the container or those workloads, there can be a security vulnerabilities either already inside the container or accessed from outside. It's like any other application, basically, right? So the problem with Kubernetes, and I outlined that before, is that you might end up in the situation of like, you have lots and lots and lots and lots of YAML files that you have to manage, and lots of independent applications that you have to manage, and you're just sitting there like, what have I done to myself? And that's obviously not a fun situation to be in, right? Nobody wants to be this poor doggo. So ultimately, the main problem with Kubernetes is its complexity, that you can easily run into situations where everything is far too complex and you don't know what's going on anymore. And I'm myself in the situation. I joined as SRE at Civo, and I hardly know everything that's going on. I know like some parts that I'm using on a day-to-day basis, and everything else I don't really know about because it's so complex that I can't keep up with it. And that's okay. And you have to be honest about yourself. I can't keep up with that because it's just too complex. Other people have to take care of other parts of the application, of the tools. So that's basically the main issue with Kubernetes. You have lots and lots of complexity, and that's why you want to keep it as simple as possible. Now, it's a bit difficult to keep it as simple as possible if these are all of the security considerations that you should take into account when you're actually deploying your workloads. And I took this image from a book called Kubernetes Security and Observability by Brendan Crane. I don't know how to pronounce his last name, and Amit Gupta, which is like one of the newer books that just came out. So I think this image summarizes it really nicely of like across your deployment lifecycle, your application being built, deployed, and managing it afterwards. You have a lot of different considerations that you have to take into account. For example, before you even build your Docker container, you have to scan your repository for vulnerabilities. Then when you build your container and run the container, you want to scan that for vulnerabilities, and it just goes on and on from there, right? You want to make sure that at each stage you basically prevent any vulnerabilities that could be introduced. Now, this is obviously a lot to take in, and people could give a talk about each of those aspects independently. So it's far too much to pack up in here. So if you're interested in that, I have some resources at the end that help you get started and dive into more detail into cloud native security. But I just want to highlight it's a lot, right? And you can't just have everything summarized in one presentation. It just doesn't work that way because it's far too much. So I just want to give you the advice: automate as much as possible and use as little as possible. And there are also some tools. I will show you some in a second. The main are Aqua Security. Then we have Sneak, and then we have Sysdig. And those are the main tools that are basically used for cloud native security to scan your containers, as well as to scan your infrastructure as code deployments and similar. Basically everything from your container security, your application security, to your actual deployments and your Kubernetes security in the end. So we're going to use another tool in a second in the demo as well, but these are like the three tools. So ultimately, in the end, you want to make use of those tools to ensure the security of your deployments of your Kubernetes-based cloud-native workloads. Now, I've written a while ago a comparison between Sneak, Aqua Security, and Sysdig, which is on the CodeFresh blog. So if you go to codefresh.io, you can find that comparison on a blog if you're interested. I have some other more detailed resources at the end of the presentation that I'm going to show you as well. But let's go over the practical tips, and I don't know if I have time for my demo. But yeah, so some practical tips when you get started with Kubernetes. The first one is box it up. You want to have everything boxed up is like contained thing. So I showed you at the beginning this image of like you have your Kubernetes cluster and then you have the different nodes running within your Kubernetes cluster. Usually you don't care about the nodes. You don't really communicate with the nodes directly. You just communicate with the Kubernetes cluster. However, what you can do is you can set up different namespaces. Now those namespaces operate across your nodes. And so basically they are just the universal like containers, and then within those namespaces you can spin up pods, and those pods are scheduled on different nodes. So what you want to do is you want to have, for example, all your monitoring tools within one namespace, all your application related tools and just workloads within another namespace, and that allows you to spin up new workloads in a confined area, let's say, as well as destroy them really easily as being part of this namespace without accidentally affecting other workloads within another namespace. Like you don't want to be in the situation where you accidentally destroy workloads in another namespace or like workloads that should not be destroyed just because you want to delete other workloads. So this is one part of like making sure that everything itself is contained. And that's something that you should start, or like you can start easily doing from the beginning when you get started with Kubernetes. The next one is access control. Like I mentioned earlier, let's go here in this image. Like I mentioned earlier, in this case, when you use something like Argo, which I want to show you in the demo, your developers only interact with Git. They don't have to access the cluster itself. And that allows you to have additional access control of like people can deploy new workloads, new resources onto the cluster through Argo CD, like tools like that, but they don't have to have access directly to the cluster. Additionally, you want to have role-based access control. Like if you have multiple people using the cluster, you want to have different access control for all those people. And so basically what Argo does is, or like what you want to do with other applications is you have here on one hand the cluster admin, like the person who can access the cluster directly, or like the different people who can access the cluster directly. And then you might have applications that are external of the cluster, but that need information from the cluster. So in this case, this application would just ask the application running within the cluster, hey, can you please provide me this information? But what we want to do actually instead is to push information out of the cluster, because whenever you pull information out of the cluster, you need access to the cluster. But if you push information out of the cluster to another application, the cluster just needs to know, or like the workloads running within the cluster only need to know where to push the information to, which makes it a lot more secure. And that's basically what Argo and other tools like that do. They don't they live within your cluster and they either pull information in or they push information out. But applications external to your cluster shouldn't have access to your cluster directly. And that's one way how you can create more of this walled garden of your cluster where people can't access it or applications can't access it either. They shouldn't have access to your cluster. Then one of the major things or like main vulnerabilities of Kubernetes is because you have lots and lots of configurations of YAML files, it's really easy to misconfigure your applications because it easily gets very, very complex. Whenever I deploy a new tool on our CVO clusters, it takes me sometimes days or weeks to set it up properly. And we still always continuously run into configuration issues where something doesn't work properly because it's misconfigured. Now, the problem with misconfiguration is that it easily can go to the extreme where you misconfigure it in such a way that you expose your cluster or the workloads within your cluster to additional vulnerabilities. So misconfiguration is a huge thing, and you can use other tools, such as a tool called D3 that I use heavily. You can also use from Aqua Security. They have open source tools that you can use basically to test your deployment, so to test your workloads for vulnerabilities and to make sure that basically everything you deploy within your cluster is actually of certain standards and has certain configurations in place. Now, the next thing is container security. Obviously, once you deploy your workloads to your Kubernetes cluster, the containers will already have the security and the vulnerabilities introduced into it once you build the container image. So you want to make sure that when you build actually the container in the first place, that you scan it for vulnerabilities and you fix those first before deploying those containers. on your cluster, on your workloads. Then the last
So
thing
wait.
Yeah.
Just to reset here for a second. Okay.
Okay.
Yeah, I just want to summarize just so.
Okay.
Yeah.
So we're constructing our cloud native security model, right?
Yeah.
One thing we have to do is scan our container images for vulnerabilities. And you have a bunch of tools and you have a blog post that kind of pros and cons each one of those tools to make sure that you are not publishing containers with known CVEs into your cluster, right? It's a very important component. Number two, we have to configure access controls into the cluster sufficiently, right? So that, I don't know, people, system admins, system accounts can't just kind of, request access to administrate the cluster without any like actual need to do that. Correct? Like that's what you were talking about with Argo, and Argo can help you solve that problem as well as how applications can access the cluster as well.
Yeah.
Okay.
So
cool.
So yeah.
No, go ahead.
No, I just
Yeah.
I was gonna say, if you're afraid that you're gonna get cut off, we're all at the edge of our seats, I think, waiting for the demo. So take your time. Don't worry about it. I'm so excited about this demo. Like I need to see it. We can take a little more. I think the audience is also excited. So
Okay, awesome. I just want to show you like a use case of how you could make your deployments happen to actually have a running application in your cluster, and to show you that it's not as scary as it all seems.
Oh no, thanks. That's awesome. Thank you.
And then the third thing, and I don't mean to just kind of drill into this, I think it's good to summarize it because the security model is so different than what people might be used to, is the actual configurations of your deployments, right? Making sure that those things are not misconfigured in the sense that you're, I don't know, like what could go wrong now? You could mount the root file system by accident, right? You could give it a higher security context than it should have. What are some of the common misconfigurations you've seen in Kubernetes?
The first one starts with, I can show you that in a second, with different services. So you have within Kubernetes, you have different ways on how you can allow access to your deployments, to your workloads. And there are a lot of different ways on how you can set that up. So you have to basically specify the ports and the networking between those different pods, between those containers. And that's actually something that I struggled for a long time with. Like, it just wouldn't go into my head of like, how do I specify this? I'm not big on networking. I'm not like really good in that stuff. Like, I mean, I got started in this space like a year ago, right? So I was like, oh, this is not working for me. So it took me a lot of time, like just trying it out, just lots of trial and error until I understood what was actually going on. And I think that's one of the best things of like, you want to try out as many different configurations possible and see what is the effect of those. Like, how does it translate? And I can show you that also in a second. In a lot of cases, you actually have, when you deploy new tools on your Kubernetes cluster, as like new tools to manage, for example, your monitoring of your application, you will use something called Helm, which is basically, Helm is like a package manager for Kubernetes. So I will show you that in a second. So you can pack up. Cool. I will show you that in a second, and I will show you exactly like how that works. To go into that, but actually a lot of tools, they specify how you can configure your application. It's really about reading those repositories and like the comments of those repositories, because that's where people will tell you how to configure everything. And if you're not used to reading like the comments of the configuration files, then you can easily just deploy the default, which is not working, or deploy something the wrong way. And I think that's the most common thing of like, once you get into the more complex environments where you use those package managers and things like that, to summarize it, that's when you will run more easily into those misconfigurations, because the documentation often doesn't reflect the complexity of what you can actually configure, which is the main problem in this space. So if you get started with new tools, please make sure to contribute to the documentation, because that needs a lot of love still, I think, to make it more accessible. And it's just something I want to point out, because it's like the most common issue that I ran into of like, and my most common frustration of like, the documentation doesn't reflect what you can do, and it doesn't tell you how to do things, and it can get so frustrating. But yeah, so let's move on, because I really want to show you the demo. Awesome. Yeah. So you want to make sure that the containers and the stuff that you pack up in your containers is already scanned for security vulnerabilities before you go to the next step of then creating your Kubernetes manifest and deploying those workloads, those container workloads. And the last thing is really like just mentioned, configure. There's so much that you will have to configure, and these are just 3 things of many things, like earlier outlined in the other slide in this overview of the things that you can actually configure. So you want to make sure, especially when you want to manage your own cluster and run more complex workloads, that you look into the ways that access can be controlled to those workloads. What if all of this is too much? Before I go into the demo, what if this is not what you want to do? You want to use Kubernetes, but you don't, and you want to have the benefits, like some of the scaling and resilience benefits, but you don't want to have to be the one who has to manage and deploy the tools to effectively manage your Kubernetes workloads. Well, there's a good news and the bad news. The good news is that there are lots of tools such as Octeto, and again, I'm not sponsored or I'm not related to any of the tools I'm showing here besides Sivo, which I'm going to use in a second. But Octeto, for example, is one of those deployment platforms where you can just tell hey, here's my workload, here's what I want to deploy, please go ahead and deploy it, and it's going to do it for you. So you can reduce the complexity as well while using Kubernetes. The thing is, in that case, that you can't use many of those fancy tools that I showed you in the cloud native ecosystem that you can use when you run your own Kubernetes cluster. So it really comes with this trade-off of how much do you want to configure versus the complexity and the features that you get out of it. And that's just something that I would be aware of when using those tools. Now, let's jump into the demo because I really want to get to that. So let's see. Hopefully, I'm still logged in. This is my Sivo platform. Sivo is a managed Kubernetes service. So you can basically spin up Kubernetes clusters. I have here one Kubernetes cluster running it's from another demo that we don't care about right now. Now you can specify different regions. You can spin up multiple clusters in multiple different regions. But this is basically the platform. When you want to create a new cluster that's running Argo CD, so I can show you how you can interact with the cluster without actually interacting with the cluster, which is told you earlier. So just making sure that you believe me that this is actually a thing that you can do. So I'm just going to specify this as test cluster or example cluster, just anything. And I'm going to specify the size of the cluster that I want to have. So in this case, I'm just going to go for medium. I could use small, but it just really depends on how many resources you want to deploy and run on that cluster. That's basically what this is about. Now, in the bottom here at Sivo, this is specific to Sivo, you can specify the different applications from this CNCF cloud native ecosystem that you want to run on top of the cluster, so you can actually spin them up when you spin up your new cluster. So in this case, I want to run Argo CD to show you how you can interact with it, like just mentioned. And then I'm just going to go ahead and I'm going to create my cluster. And this should take about 2 minutes to spin up the cluster so I can use it. Now, in the meantime, let me show you what I want to run on that cluster. Are there a question? You just dropped in. I feel like there's a question. All good?
No,
All good.
sorry.
Okay, awesome. So this will take just a few seconds to spin up. And then once it's spin up, I want to deploy. Let me just show you 1 second. I have here some resources that I want to deploy. Now, here's a deployment that basically specifies that I want to run 2 replicas, so 2 pods basically of my application. Here's the container image that I want to run. Now, at the beginning, I'm going to deploy actually 7.0.0, and then I'm going to update it to show you how Argo CD would actually interact with everything and make that update happen. And then I basically specify my resource limits of that this container is allowed to use. So this is my deployment. And then I also deploy a service that's going to allow me to access my deployment, because the deployment just specifies, hey, I want to spin up 2 pods. And those 2 pods are then running within my cluster, and they are managed by the deployment. Now, the pods can die and live and die and live. If I would connect directly to the pods, I might not be able to access them because the pod that I connected to just died, right? And there's a new pod in place. But what the service does, the service will actually connect to the deployment. So it's just going to directly connect to the deployment without actually me having to connect to the pod. So even if the pods die and live underneath the deployment, the service is just connected to the deployment, so I can actually access my application. Now, this is what I will do right now, just for demonstration purposes. And then what I mentioned earlier, once you get into more advanced use cases, you can use these Helm charts. they are called. And basically a Helm chart is just basically this package of files. So you have here like different YAML files that are used for different purposes within your Kubernetes cluster. And you can modify and those YAML files of like different values and so on. And these values are specified in this values YAML file, in this chart, basically. And as it's packed up, and then you can deploy just the chart without having to deploy those independent resources. So I don't have to just deploy the ingress, the deployment, everything separately, but I can just go ahead and deploy the entire chart. And that's what you would do with more advanced use cases. You would just have this entire package thing deployed. But I'm not going to do this in this case. Just like as an example, once you go into those cloud native tools that are more advanced, you would use these charts to configure those tools and the deployments. And it would tell you within those YAML and within those values YAML files, it would tell you exactly how you can configure the chart. So you are less likely to mess it up, let's say. Now, in this case, I want to deploy the deployment and my service. Now, I told you earlier about a call called the tree. And in this case, I can run the tree test to test the deployment that's actually fitting, like it's complying with all of my policy configurations that I have in place. So the tree is going to basically run it against the policies that I have set up with it, and it's going to make sure that everything that I have in place in this deployment. So for instance, if I remove my resources, I don't specify the resource limits of my deployment, and I run the same test again, it should now throw errors of like, oh, it's not throwing errors. It should throw errors of the deployment. So that's the idea, demo purposes. But we want to specify. Let's go back. We want to specify our resource limits within this deployment. I'm going to check after the demo. I'm going to check why this didn't work properly. But ultimately, you can use tools like the tree to test the deployments. Now, we want to go ahead and connect with our cluster. So I'm going to go back. And now our test cluster is running. So I'm going to download the kubeconfig. The kubeconfig allows me to connect to this cluster that's basically spin up on Civo. So I'm going to go ahead and then connect to and in this case, we call it test cluster. So I'm going to just connect to my test cluster. And now I'm on the test cluster, and I can kubectl get nodes. I can show you the different nodes that are running. So these are all my nodes that my cluster has that I showed you earlier in the drawing, let's say. And on this cluster, I have my get namespaces. So I have my different namespaces here, and I have my Argo CD namespace with all of my Argo CD based resources. Now, Argo CD is one of those more complex tools. So if I kubectl get all in namespace Argo CD, it will show me everything that's spin up, more or less everything that's spin up in my Argo CD namespace. Now, this is all constrained within the namespace, and that will allow me to easily just delete that namespace and delete all of the resources that Argo CD is connected to. Now, in this case, I actually want to run Argo CD. So I'm going to go ahead and say kubectl port forward and this. So basically I connect to the Argo CD service that basically then connects me to the front end. And let's also go here and connect to our new cluster. That was from a previous test. So here I'm connected to the same cluster, and now I want to access my Argo CD namespace, and I want to tell it, please make a deployment happen so I can deploy my application. I can access my application, basically. So to do that, I need actually kubectl get secret. Let me find here, get secret. And it's giving me the secret to connect to Argo CD, basically, to log in. So I can say Argo CD and log in to my running instance. So just providing the username and the password to log in. And then once I'm logged in, and I can do the same on the website. So I can go ahead and I can open it up. And now it's just running locally. If you would use this in a production environment, you would want to probably have a proper access to it. So admin, and then I'm going to just provide the password. that is stored within my Kubernetes cluster as well. So as this is what Argo CD looks like, and here are my applications. Now I'm going to tell Argo CD now where the GitHub repository is. Like this GitHub repository is the same that I have locally as well right now, running like cloned, and I want to tell it basically deploy these manifests. So when I make any changes to my application, it will basically just pull the changes from this Git repository, and I won't have to directly interact with my Kubernetes cluster. So everything up to this point is done by the cluster admin. And then I would want to go ahead and say Argo and then CD and then create my React application. And in this case, I would use the default namespace, which is not the best practice. So you would want to create a separate namespace instead. And I don't know why it created it. I hope it created in the right namespace. So I basically told Argo CD to create this application that's based on my Git repository, and it's in the folder manifests, and it's deploying it on the Kubernetes cluster that Argo CD is running on top, and right now in the default namespace. Now, when I go back to the UI, it now pops up here. So it's managed through Argo CD now. Basically, Argo CD knows now about my application, and I can sync the application with my Git repository. So now it's actually creating the resources for my application, and the sync failed, which is not good. It's probably because of the namespace that I right now messed up. So let's try this again. Let's try this again with kubectl. I'm just going to create a new namespace, create namespace demo. And then we're going to just put this, because I couldn't find the namespace, into the demo namespace. And it's going to, I can't. Okay, let's delete the app first and then just spin it up again. Let's do that. So here we're going to delete this application that's running right now. And then just spin it up next without a typo in the namespace. So we're just going to do that. And let's just say default, and hopefully this is going to work now. Okay, so it's spinning up in the right namespace, hopefully. And I could also sync through the CLI, through the Argo CD CLI, but I'm just going to sync now again here through the UI. So now it hopefully goes ahead and synchronizes between the Git repository and my running application. So as you can see now, it's creating those pods. This is the pod that it's spinning up right now that I showed you earlier from the deployment. That's spinning up. And now we can go ahead and get all the resources that are running in my main namespace. And as you can see, I have here my 2 pods that I specified I want to run, and I have here my service that I can now connect to. Now, those pods, they will die and live, and I want to just connect directly to the service that's over here. So I'm going to go ahead and say kubectl port forward, and to my React application. I'm just going to connect to that. I'm going to show you that it's running. And then we want to update that application. So localhost 3000. And this is my application, how it's running. And now I want to make updates to it. I basically changed just the color of the buttons. And I want to deploy, run this update. So what I'm going to do go and do now is just within my Git repository, I'm going to push the changes. So I now updated 2 files, and I want to just push those changes to Git, and then Argo CD should pull those changes out of Git. That's the magic, which it's supposed to do. So Git commit, and then tests, and Git push origin main. And I'm just going to push those changes. So now it should know about the changed image. So basically, I updated here the image to set it to 8.0.0. And that image is based on the changes that I did on the coloring of the application. So now I'm going to go back to Argo CD, and it should now get out of sync soon, this application. It should realize it's periodically checking, is it out of sync or is it synced? But it can also force the synchronization between Git. So now it's spinning up the new pod with with my application, with basically my new deployment. So this is my new deployments, and it's scaling the other two down. And that's part of the magic of Kubernetes, that basically, let me maybe zoom in a bit more so you can see it better. So this part is going to get deleted because it has the old state of my application. And these two parts are the new state of my application that is spin up right now. And I don't have to interact directly with the Kubernetes cluster. I just push to get those changes. And now it should automatically, basically, Argo CD is responsible for deleting the old resources and spinning up the new resources. So I can now go ahead and say, well, in the other one, the one that I'm connected to, I can again access my application. And now when I'm opening my application, it should have the new buttons. And here now the buttons are red without me actually working with the cluster. I think this is pretty amazing because you don't have to interact with the cluster. I can just give you access to my Git repository over here, and then you can make changes, and basically anything that you put into the manifest folder will get deployed to my cluster without me having to give you access to my Kubernetes cluster, which makes, like in a case where, for example, we work on a open source repository, I don't have to give you access to the Kubernetes cluster that runs the application and everything with it, but you can just interact directly with Git, and we can have like all the measures directly within Git in place without having to have additional security measures like on that level in our Kubernetes repository. And that's basically it. That's what I want to show.
No, that's cool. And then you could control like how you merge that PR is like the last sort of that would be like the final line. I don't know, the final check, right? So how you merge those PRs before it goes into prod or wherever it's headed.
Yeah, so that would give me, like, if I would give you access directly to my Kubernetes cluster, the risk that I'm running into that I would have to trust you to some extent, right? I could give you obviously access to just modify resources and spin up new resources instead of deleting resources, but you could modify anything in that case. Or you could spin up resources that are malicious within my cluster. And I don't want you to be able to do that because I might not trust you to that level, especially if you're not working in the same company or same team and you don't know what my team actually does, if you're working in different teams and so on and so forth. Like there are so many considerations that you would have to take into account that you don't want to have to worry about. So instead, what we're going to do is that some people are responsible to checking the PRs, and ultimately only things that get approved to the main branch they then get deployed to my Kubernetes cluster. And you don't have to have, as a developer, access to the Kubernetes cluster where you might risk messing things up, let's say. But you only have access to the Git repository, and you can create, like most other people, PRs.
Got it. So for those that aren't familiar with Argo, how does it work under the hood? Are you pushing YAML? You push YAML or Helm changes to GitHub. Can it handle both? Can it handle both YAML and Helm? And then Argo will be like, oh, changes in GitHub. You know, I see changes, and now I'm going to publish those to production.
Yeah, so I hope you can still see me. It was like right now. Yeah, awesome. So Argo depends on like it can handle any YAML manifest, like anything YAML-based, any kind of Kubernetes deployments. It can also handle customized files, which is another way of deploying Kubernetes
customized
workloads.
with a K.
Yeah, customized with a K. Yeah. And so it can handle those. It just depends on with this initial setup of like when you create the app, what you tell Argo to manage. If you tell it to handle customized files, it will handle customized files. If you tell it to handle the pure manifest, it will handle the pure manifest. If you tell it to handle the Helm chart, it will handle the Helm chart. And then you can make from there changes to each of those resources depending on which ones you use. If you use a Helm chart, you can then make changes to the Helm chart, and it will deploy those and manage the Helm chart. So it's basically, think about Argo as just like anything that you would install on your computer. It's just something that you install on the Kubernetes cluster. It's basically the application in itself. Just because it's running on a Kubernetes cluster, it's defined as YAML files itself. So Argo is basically a Kubernetes resource in itself. And anything that you deploy on your cluster will be Kubernetes resources. So that's what Argo is. It's just like a different type that you have installed in your Kubernetes cluster. And then from there, you can tell it to manage any Kubernetes resource, basically. Yeah.
Earlier, you had said that it's important to get support, and especially as you're learning about Kubernetes and containers. And as such, obviously, the Cloud Native Computing Foundation is fairly important. It plays a great role in that. Can you talk a little bit about that and also your role as an ambassador? Because I mean,
Yeah.
we can't just talk about how you're the top without giving it some context, right?
Yeah, no, that's a great question. So the CNCF has actually a lot of different hats, let's say. So I mean, on one hand, it organizes lots of different webinars and also the KubeCon conferences. So it's on one hand this bringing people with the knowledge into a room with people who want to learn about these things, right? So there are regular webinars where you can where they basically invite people to talk about things like this. That's one thing. And then there are lots of different initiatives. There's since just a few months, there's a student initiative that's focused specifically on university students, getting them on-ramped into the CNCF and providing the support and the resources for students.
Nice.
Then which is pretty amazing because it's basically when you're a student, you often have problems accessing of like, okay, how do I get started in this industry or that industry? When you already know you want to maybe focus or you want to explore even, right? So it's providing the like student programs and student run programs as well. So there are also independent meetup groups. Some of them are focused on students, some of them are regional. So it's really diverse in that sense. So there's probably something for every age group and every skill level. And then the other major thing is hosting those projects that are given to the CNCF as part of this landscape, right? And with those projects, the CNCF is running also mentorship programs. So you can also get started and become a mentee and get basically further support and getting started with those tools and contributing to those tools if you want to contribute to those open source projects. So there are lots of different aspects that the CNCF does. Now, as part of the ambassador program or ambassadors as part of CNCF, what we do is we create additional resources, more accessible resources. So for example, on my YouTube channel, that's what I got started with. I created lots of different YouTube videos of me getting started with those tools and with Kubernetes specifically. And there are lots of other ambassadors who do their own unique things to create more knowledge sharing and enhance knowledge sharing in this space. And that's basically the main focus, to bring people together to learn about Kubernetes and cloud native, the cloud native ecosystem, as well as creating new resources to make it more accessible.
Well, thank you for being part of that. Yeah.
Yeah. Congrats on the Ambassador Award.
Thank you.
Cool.
It's made possible through this amazing community. So.
All right, I think let's move on to our giveaway. So
awesome.
Kind of exciting. Here we go.
Suspense. I was gonna do this.
Who is it?
You already oh no, I entered myself by mistake.
Ooh, all right. Yay. Marcus Acosta.
Congratulations.
All right, so I think they have to
get it?
Yeah, I think there is an email. Nancy, what is the email that let me get the email that you have to send to. We are going to send, we'll put that up on the screen in a second.
Yeah, we'll put that up on the screen, Nancy, here in the back. I'll share an email. Please contact us by, I'll give you the deadline about an hour after we end the show to let us know that you were here with us live, and we will send you the information for the giveaway. Thank you, everyone, for participating.
Cool.
Really quickly. Wait, this is before, but I have 3 more slides that I need to show. First of all, I hope we can share the slides afterwards or something. So here's this amazing, look for awesome Kubernetes security. It's like a Git repository, this GitHub repository with a bunch of resources on Kubernetes security. So if you're interested in learning more, check that out. It's somebody who just curated this amazing list. And there's this amazing cheat sheet by OWASP that I found as well, which you should check out as well if you want to get more information. And then here's more of like self-plug. This is like the website that I started as part of my Kubernetes challenge of 100 days of Kubernetes. Now I'm at day 40 something, depending on my time, how much time I have available. So check that out if you want to contribute and help also others get started in the Kubernetes ecosystem. I would love your contributions. It's a GitHub repository, so you can make changes, create PRs, and help me advance those resources as well. So please, if you're interested in that, also if you're just getting started and you're getting started with any of those topics, I would love to have your input as well. That would be very, very valuable. And last plug is, that Sivo is hiring. We are hiring for 2 Go developers and 1 site reliability engineer, senior site reliability engineer. We have amazing 4-day work weeks. So if that's something that you're really curious about and are interested in, then yeah, please do reach out. We have amazing perks and what else? It's completely remote, so you could be anywhere. And we would love to hear from you if that's your skill level.
Cool.
Yeah. Love the 100 days of cloud offshoot with 100 days of Kubernetes. Very cool.
Yeah, and
Yeah.
we'll post all of these links in the show notes.
Awesome.
So for
Awesome.
anyone who's scrambling to search them up, we'll post them.
Awesome.
Cool. All
Perfect.
right. Any final thoughts here, Anais or Amy?
Well, thank you so much for having me. That was really amazing. I hope you enjoyed it. I hope it was
it
useful.
was great.
Yeah, thank you.
Awesome. Amazing.
Cool. We have 2 shows coming up that I just want to remind everyone on. Next Sunday at this time, Eastern, I don't know, the daylight savings time. I don't ask me about the time. Here's the time. OAuth and OpenID Connect Clearly Explained with our guest, Nate Barbatini. So please join us. And then we have another show on Friday, November 19th at 12 a.m. UTC. This is with our Australian friends, testing your assumptions with red teaming with the guest, Alex. So please tune in, join us. And thank you so much, Anais, and thanks, Amy.
Thank you.
We hope you have a really good day, and we'll see you next time.
Bye.
Bye-bye.
Bye.